Okay guys, now that we have practiced our proportions, our dilations, and our similarity statements, we can now look to see and prove if triangles are similar. So triangles are said to be similar if their corresponding sides are proportional and their corresponding angles are congruent. Similar triangles are the same shape, but not the same size. Okay. So to prove if triangles are similar, we can use similarity postulates. Okay. So we can, first one we have is angle-angle similarity. So the angle-angle similarity is saying if two angles of one triangle are congruent to the angles of another, then the two triangles are similar. So in this example, we have that angle B and angle F are congruent, angle A and angle E are congruent. We can tell this by the number of angle marks that they have. So since B and F have one, they're congruent to each other. Since A and E have 2 marks, we can say those are congruent to each other. So we can then make our similarity statement by saying triangle ABC. So I said from the angle that's congruent with 2 lines to the one to no lines, so I have to do the exact same thing for my other triangle to show the proportional and corresponding sides. So I'm going to say ABC is congruent to EFG. Okay. Now, I want to ask, why 2 angles? Why is it just AA? So we know that all angles in a triangle, so all 3 angles, sum or add up to 180 degrees. So if we know one angle and a second angle, we can figure out the second one by doing 180 minus angle A minus angle B to get our final angle C. Okay. So this technically could be called the angle-angle similarity, but that would be redundant. We can just prove a triangle similar to another with 2 angles because the triangle angles inside add up to 180. The next similarity postulate we have is the side-side-side similarity. It's often abbreviated as SSS. So if the corresponding sides of 2 triangles are proportional, then the 2 triangles are similar. So if we look, again, I would start with my smallest side. So my smallest side here is 3. My smallest side for ABC is 9. So 3 over 9. And then I would find my biggest. So my biggest one is 5 and 15. And then the last one would be 4 over 12. Are all of these ratios proportional or equal? So 3 over 9, that's going to simplify to 1/3. 5 over 15 also simplifies to 1/3. And 4 over 12 also simplifies to 1/3. So because all sides of the triangle are proportional, we can now say that triangle ABC, so I went from the middle to the longest side. So I need to do the same to show the proportional and corresponding sides. So triangle ABC is going to be similar to triangle EFG. If you wanted to, you could also go in a different order. So we could say triangle, we can maybe start with the short side and go to the long side. So we could say triangle ACB is going to be similar to triangle EGF. So the order you write the statement in does not, the first one doesn't matter. The second part of the statement has to correspond to the correct sides though. The next similarity postulate we have is side, angle, side, often abbreviated by SAS. So if the lengths of two sides of one triangle are proportional to the lengths of the corresponding sides of the other, and the angle between them, between is important, so if the angle between them are congruent, then the triangles are similar. So we can see in our example, we have triangle ABC and triangle EFG. So we're given these two sides and then the angle in between them. So let's see, are these sides proportional? So we're going to do our small over small. So 6 over 10. Does that equal our other side, the larger numbers? So 6 over 10 is going to simplify to 3 over 5. 9 over 15 also simplifies to 3 over 5. So the sides are proportional. Then we know that the angles are congruent because they are both marked with one single arc. So these sides are proportional. The angle between the two sides is congruent for both triangles. So we can then say that triangle ABC is similar to triangle EFG.